Good afternoon, everyone. Feeling light-hearted? Nice to back-to-back nice talks, right? So I'll just change the theme of this conference, and I will not talk anything about two words. One is project management, second is innovation, right? These two words you both read by now. Just I'll give you a little example or maybe a definition of manager what I read in when I was in school. I read a book named as Organizational Behavior by Steve Robbins. And this guy has some knack of writing very, very funny definitions. Not funny, but he was trying to be accurate, but we found it funny. So manager is the person who gets its job done by others. That's what the definition of manager. And if you go back in time, right, majority of us are born managers. Remember when your mother used to say, okay, fill the water bottle in the fridge, what do you used to do? You used to delegate to your sibling, and that sibling used to delegate to the other sibling, and finally somebody has to do it, but not you. So that's where being a manager is not a bad thing. It is actually something interesting that we have been doing for so long. The topic of this discussion is artificial intelligence versus human intelligence, right? So these days you are hearing a lot of things about artificial intelligence and machine learning and so on and so forth, how it is going to take over the world, whether it is going to take your jobs away, which is a serious threat. We will talk about like what this hoopla is all about. Is it really that serious, or it is so difficult to understand, right? So as the word says, artificial intelligence, it is artificial. And I will give you 2-3 simple examples just to explain what these algorithms are talking about. So initially, when we built machine, the idea was that they will empower us. But actually what is happening right now, we are thinking that machines are confronting us. But that is not true. What is happening, machines are actually empowering us, right? So they are helping us in doing our jobs. Moving on, how this algorithm works actually. So they need two things. One is data, another is how to process the data. So first step is very important, which is like data gathering. If you go like 20, 30 years or 40 years back in time, how you used to gather data? You used to talk to each other, right? By talking to each other, we used to gather information that we used to process with human intelligence and provide some insight or whatever, gossip or something live or truth, anything. So what happened in digital is, things remain same. The chat is still the best and possibly the popular way of gathering information, but we have added some more dimensions to it, like print media came in. So you are reading news, you are reading magazines, articles, and so many other things. Further advancement in time gave you these. Now social media, digital social media platforms, Twitter, Facebook, all those things, right? So after this, what we have to do, we have to structure this particular information, right? So when you are gathering information by just talking to people, you are gathering it in your brain, right? You are arranging some sort of, you have heard about this mind map, how to increase the memory power and all those things. They were talking about this thing only, or organizing this data. But as the data size is getting huge, just imagine like on LinkedIn or Facebook, you have close to 400, 500 friends, right? You just cannot keep information about them. But in real life, you have maybe 4 or 5 friends. And I'll take this example further. As Pawan said, you go to social media, you have so many friends, but in real life, you need only 5, right? And it's a very interesting correlation. He was talking that all managers will die. Everybody will die. And then he said, you need 5 friends. 4 possibly to take us over to graveyard maybe. And the 5th one is just to manage everything. So maybe a project manager for the last ritual. So what is happening here? We are again structuring the information in some database or somewhere. And you just need not to worry about it. Then what happens? You add some dimension to it, right? So this is a typical example from Thomson Reuters itself, how we are doing it. So we gather all sort of internal information we have, and then we add something other which is not in our control. For example, economic health of the world, say, or maybe some regulations, or maybe H1B effect, or oil crisis in Gulf, or some war happening around Middle East zone. So we cannot do anything about it. How we can capture that information and still be robust in terms of our retention and growth initiative, right? It's definitely complex, very complex, and there is no need to even get into everything, get all the data into your head. There are machines which will easily do the job for you. All you have to do is train them properly. That's what they do. So this is a typical setup. You feed something in, it will give you something out. I'll give you just a little example over here how we can get the information and how we are processing it and sending it across. Just go back in time and just imagine you're a 3-year-old kid, and I'm talking about my son. So I started noticing this thing. Whenever I'm making some call over phone, he will come and say that, okay, show me whom you are calling. So he will see that number, or in fact the name over there, and he will just say nothing and he will go away. And every time I make a call, he will just ask this question. And one day I saw that he can make calls to my parents and my sisters. So I asked him, like, how you can do this? So he said, because you were telling me that day, this is say mommy's call, nanny's call, and so on and so forth. He was able to recognize just by seeing those alphabets. So this is what is happening in all sort of algorithms. You are showing a lot of images or data to the algorithm and it processes it. So this particular case wherein he was just seeing the picture or name over the phone and he was able to reproduce it. These kind of algorithms are used in all sort of face recognition algorithm or image recognition algorithm. But can they make mistake? Of course, yes. So one day what happened, my wife was calling her mother and he came in and said that, whom are you calling? She said, it's your nanny. So he took the phone and he was reading. She wrote her mother's number as mom, right? So he started reading saying that M-O-M nanny. So I mean, he made a mistake, but he learned from it. So we corrected him, right? So this correction process is nothing but known as reinforcement learning, right? It is nothing but providing the feedback and correcting the algorithm. That's how any sort of machine learning algorithm will work. There are multiple different sort of algorithm. If somebody says that, okay, this is the best algorithm, just take it by face value that they are lying, right? There is no single best algorithm, there is no holy grail for it. Every problem, every situation has a different solution and definitely a different algorithm. Right? I will just show you a couple of examples here and maybe I'll take an example of neural network, how we actually process a neural network. Okay, so the last one you see is a neural network. So we heard a lot about neural network, deep neural network, deep belief neural network, convolution computing and all those things. Essentially, in nutshell, what it is this. Say for example, I say, recognize this image over here, right? Possibly some of you might recognize it, right? Or let me say that, okay, talk about something about your latest vacation. So what you will do? Immediately your brain will start processing the events of that vacation. At that time, the information about your work is still there in brain, but you are not processing it. What is happening? Only that part of your brain which has stored the vacation related information is active. So you are processing and telling about that particular event. The moment I ask you about, okay, tell me something about project management, immediately that vacation part will go away and other thing will start processing the information. So what is happening here, all the information is there and in your brain it is very well connected, but only that is highlighted or activated which is being asked for. So similarly, any neural network, there you see all those circles are basically nothing, artificial neurons, and they are activated only when we ask a particular information. So that's how any neural network will work. Now, if they say deep neural network, just imagine instead of those 3 circles, they are using 30, 300 or 3000. Further deep or say it is even deep belief or whatever terminology they give it, just imagine they are increasing this number of circles and more number of columns. That's it. That's what they are doing and nobody really understands what is happening inside. And that's where the biggest concern is. If AI is not comprehensible by those who are producing it, so there is no certainty whatever results they are producing is always right. So typically this is a general neural network. And one more algorithm I'll talk about is decision trees. So what happens in decision trees, very simple algorithm. You ask questions. So what your kid does, any kid in fact around 3 to 4 years old, in a day they will ask around 300 questions. 300 questions, right? And every question is a learning exercise for them, right? So they will ask you something, you will give some answer, they will store it, right? They will ask another question and subsequent questions they will keep asking. And they are gathering all this information. And next time when you ask something, possibly from that information they will process and give you the answer. And that's how the decision tree works, and majority of the modern algorithm given fancy name like random forest, gradient boosting, extreme gradient boosting. The fundamental is this: ask questions, based on the answer, ask further questions till you get what you want. This is how any algorithm will work. Within Thomson Reuters, okay, so this is interesting, right? A lot of people talk about innovation and all those things. So we should be proud of being at Thomson Reuters, because I have been to multiple conferences, and when I see the research level of other companies, I feel very good, because Thomson Reuters research level, at least in data processing and in artificial intelligence, is way too ahead. I think at least 3 to 4 years ahead. It's just that we are not known to public. We are not producing any products which is actually given to public in their hand. It is mostly for corporates. That's why we are not that well known. But you can imagine, like in 80s, Thomson Reuters was using email. Even before you have heard of the concept MapReduce Hadoop, Thomson Reuters had that some variant of that to process all sort of information from Exchange and delivering it right to the customer. This is one example wherein you can mine the sentiment about the company from Twitters. From tweets that are being generated on the Twitter, right? So this algorithm is there in our product, Thomson Reuters icon. Those who have access, you can go and see it. This one is actually free, and it is being developed. This algorithm is being developed by our team here in Bangalore. What they do is, you take out any text and paste it over there. It will automatically identify various things in it, like what is the company, what is the place, and who are the people in it. And definitely it can make mistakes, but this will give you a pretty good information about your article. Good thing about this is, from raw text, suddenly you have created a very, very structured data which you can process and generate insights. So this is something happening within Thomson Reuters. You can go to the websites of Thomson Reuters Data Innovation Labs, or maybe Technology Development, and earlier R&D, now it is merged with Data Innovation. Those guys are doing some real good stuff, and I think every month or every 2 months they are organizing some talks over WebEx, 1 hour talk, wherein they are talking about multiple algorithms. But whatever machine learning we do, we have to be cautious because of this simple reason. The conclusion that we draw could be wrong, right? So everybody who drinks water dies. Fair. I mean, it's a fact. If you tell a robot, it will say it's a 100% true thing. But it's not meaningful, right? So whatever conclusion you draw from these results has to be meaningful. That is very important. And this is really good. It says you have lots of experience in developing models, and you can predict everything. But this HR lady is talking to him and saying that even though you have so many years of predictive modeling experience, you couldn't predict that we won't offer you the job, right? So you have to be precise in the term. Whatever your algorithm is telling you, it is just a number, right? It has a very limited information. You have to take a call. Now, with this, I would like to end my talk with just one simple statement. Artificial intelligence or machine learning is already here, right? And it is increasing at much faster pace than we can imagine. For example, if somebody tells you that within 10 years, artificial intelligence is going to possibly take over a particular sector, you have to believe it. Maybe not in 10 years, it could happen even before maybe 7 or 8 years, because of two simple reasons. One is, in 90s also, this artificial intelligence concept came in 90s. It was at boom, but suddenly it died down. The reason was, at that time, we didn't have enough computing power. Right now, your phone holds much more processing power than possibly 1975 supercomputer, right? Second and most important thing is vast amount of data available, right? When you're posting your information on Facebook or Twitter or Instagram, anywhere, all these companies are reading that algorithm, or reading that information, and they're processing their algorithm. So anything that can happen with in artificial intelligence domain within 5 to 7 years is plausible and can happen. So all you have to look out for, do you want to confront with this, that no, it cannot take my job, or it cannot do anything to me, or you want to go hand in hand? My thought is, going hand in hand is the best way to amplify your powers. With this, thanks a lot for listening.